Hello everyone. We are going to talk this week about time series analysis. And time series analysis on the outside seems pretty straightforward and pretty simple, but always we want to try to get to the most accurate predictions we can possibly get to. And that means reducing the error, which error is typically calculated as the difference between our prediction and our actual for months where we know both. So we want to create a model that reduces that amount as much as possible. And that brings you into some pretty complex methods in time series analysis. We're not going to go that deep though. I'm going to give you a bit of a break this week and have you just take a look at time series analysis and get an understanding of how you would use something called moving averages to come up with a basic assessment of what the next period's predictions should be. But we're not going to worry about correcting for error and the like, at least not in this section. So time series analysis can be best understood using what's called the news vendor problem. And the news vendor problem is where we're really trying to match supply and demand. And that's where we're trying to anticipate what our demand from our customers is going to be. And by doing that, we can purchase just enough product to be able to satisfy that demand. We don't want to go too high, because if we go too high, then we've wasted money on product that isn't going to be sold. We also don't want to go too low, because if we go too low and suddenly we have customers who can't purchase our product, we're in trouble and we're not going to make as much money as we possibly could. So really what we're doing with time series analysis is another maximization. It's a maximization of potential profit that we can make by making sure that our supply and our demand match. So this is a really common issue, and a good example of this, maybe a little bit more detail, is if you were in charge of operations for a retailer. And so suppose you make operations decisions for a retailer, the retailer, you order from a supplier and you sell that product to customers. So when you order from the supplier, maybe you pay $3 for the product, and that is your wholesale cost. And you turn around and you sell that product to customers for $10. So the ordered products are then placed on the store shelf, and customers arrive at the store to buy the product if it is in fact available on the shelf. So they're ready to pay $10 for it. So imagine now that you have 100 customers that want to buy from you, and each one is willing to pay $10. There's $1,000. You made $1,000 worth of money, 70% of which is profit on your sales. But imagine that you don't have 1,000. You order 1,000, or I'm sorry, you order 100, but you don't have 100 customers. So you have 70 customers that come in. You've got 30 units remaining on the shelf. That's 30 times $3. You've lost $90. Now you made more than that in profit on the 70% that you sold, but you still lost money and you didn't maximize your profits for the day. Imagine on the other side, though, that you have 100 units on the shelf. You have 120 customers that come in. Well, you've just lost $200 because you ran out of product at 100 and the last 20 customers weren't able to purchase it. So again, if we have too much, we lose the cost of the goods, and we have too little, we lose the potential sales. And the reason why this is referred to as the news vendor problem is because it's a classic example of how many newspapers do you buy every day to satisfy the number of customers that are going to come in and buy a newspaper from you. And it's kind of an old, reference, but it still works. So what we have to do in order to get ourselves in a spot where supply and demand meet is to forecast, and we have to forecast using the best information that we have. So when the best information that we have really is going to be past data. Now, past data is used to predict future outcomes, and that's great if there are no fluctuations, but there are fluctuations, and there are things that change. So the past data is not always a good predictor of future performance. We want forecasts that are timely, so we can get them, day to day even, that they're trustworthy, we can believe in them, and they're accurate. Forecasts can be on data that is flat, and that is if you have sales that have pretty much stayed the same, and maybe it's a product that is very mature, it sells a certain number every month, and it's not likely to fluctuate too much, then we can make easy forecasts on that data, because that typically winds up being the mean of the past sales, the mean of past months. But it can also be, forecasts can also be on data that are impacted by things like trends. So for example, if you've got a technology, Alexa is a good example. Amazon Alexa probably has trended, it might be actually flattening out by now, but in its first couple of years, the trends were, I'm sure, pretty spectacular, and they had to try to make sales forecasts based on trending data that was trending up dramatically. At the same time, sales forecasts can be based on products that are old and mature, and they're not selling as much, so they're trending downward. So there's a complication in being able to predict that. And then there's also seasonality. Lift tickets for uh, ski resorts is going to be a great example of something that is seasonal. It's seasonal, but it's predictable. But it could also be impacted by trends. If it's seasonal and it spikes the same in winter every year, then it's fairly predictable, it's fairly flat, and that's an easier thing to predict. But if it's getting bigger every year, every winter we get more, that's a little harder to predict. And then you've got trends and seasonality that are actually kind of co-complicating your forecasts. So how do we make forecasts useful? Well, sometimes the future does not look like the past, so that brings in a complication. We talked a little bit about static data forecasts. We can use the average of past periods. We calculate the average for each of the past periods, or we calculate the average for all of the past periods, I should say, and use that average as your projection. And we can actually sort of determine the extent to which that's actually working for us. If we have past projections and past actual data, we can test out that theory to see if that's really working for us. Or we can do something called moving averages. Moving averages allows us to not go all the way back to the beginning, but just goes back a certain period or a certain distance. We can go back the last 6 months or the last quarter or the last 12 months, and we can look at that and see how accurate that will be. More on moving averages. Let's look at an example. I'm actually going to pull up an example in Excel. This is the Swords file from the book. Now, he goes into a lot of complicated Excel work on doing simple exponential smoothing and showing you how you can do all kinds of great stuff. You're welcome to work through that. I think it gets pretty complex. I think it's useful. I think it's easy to follow. And most of his stuff has a bit of a challenge, I think, sometimes in tracking him. But this one is actually pretty accurate, and it's pretty easy to follow if you want to do it. But what we're going to do is we're going to actually use his file, but we're going to do different things with it. So what we're going to try to figure out is he's got 36 months worth of sword sales. And we're going to try to forecast just month number 37. And this will bring up to light actually some questions that we want to ask ourselves when we are trying to make that forecast. So we'll look at the mean over different periods. We'll look at the standard deviation for those means and see how that can help us better understand where our overall trends are going. And then we'll try to see if we can make a good, solid prediction. So let me cut over to the Excel file. There it is. All right, I've already done some work for you. So month number 1 through month number 36 are all down here, and we see our sales. Our sales start at 165 in month 1 and go all the way down here to 304 in month number 36. Okay, a couple questions we need to ask ourselves, and this is a visual actually, a visual of the months over the last 36 months and the sales. When we're making projections for month number 37, we have a couple things we need to ask. One is, what does, and the visual really helps, what does the visual actually look like? Are we increasing? Are we trending? Do we have seasonality? And so this helps us understand how we can use moving averages, or basically if the data are static enough, if we can just use the whole data set. So we start over here at 100 and, what did we start at? 165. 165 is our first sales number, and that's in month number 1. We end up at 304. That alone seems to suggest that using the entire set to forecast the next month probably won't work that well. But let's actually look at the numbers. Come down here and we look at the mean. I calculated the mean for all of the sales from the first month to the 36th month, and I come up with 186.02. 186.02 seems to track fairly well with some of this data, but it seems like all of a sudden around month 20 we're starting to see a trend, and that trend is starting to go up above 200, ducks down here, but then it seems to sort of take off. So that seems like there's some recency, and that the use of the entire data set may not be the best predictor for month number 37. Let's come down here and take a look at last 12 months. So this is, now we're getting into moving averages. And moving averages for the last 12 months, this is just our static last 12 months, and our mean is 217. That looks like it could be a better solution. It could be a better solution in the sense that these data that are coming in for the last 12 months is a pretty good period too. That's quite a number of months. They are showing that they are right around 217. Many of the data points are kind of close to 217. But we can account for that spike at the end. That spike at the end jets up quite a bit, but it is only 2 months. But still, let's take a look at the last 6 months. The last 6 months average is 236, and 236 gets us a little closer, but I think what we might have is a standard case of an outlier. And we have a standard case of an outlier because of seasonality, and I'll talk about that in a minute. But I'm going to suggest that 236 is probably going to be off because in the month number 37, or month number 37, which is typically the January month, I suspect these are going to come back down. And here's why. We talked already about trends, and it looks like we are seeing a trend in this data set. So that's inching us up. So we probably aren't going to use the entire average of the data set as our predictor for month number 37. The other thing we can look at is we can look at the standard deviation. The standard deviation is a good indicator. 68% of our data points fall within that standard deviation. So if we're seeing that from one standard deviation above 186, we're going to get around 210, 220 or so. And we're largely above that. We're largely outside, in many cases, outside of one standard deviation. That's another indicator that the entire data set is probably not a good, useful predictor. The last 12 months seems to be a better fit because 68% of the data points will fall within 33.90 of 217. That fits in most cases, except for these two that are way up here. Actually fits for this one, doesn't fit for the last one. And then the last 6 months, again, I think we're kind of being pulled off a little bit because of the anomaly. All right, let me get back to what I was talking about earlier, and that is seasonality. We saw the trend, now we're going to look for seasonality. Look at every 12th month. On the 12th month of the first year, we have a spike. On the 12th month of the second year, we have another spike. On the 12th month of the third year, we have yet another spike, and this one's in fact much larger. So we not only have spiking for seasonality, looks like right around Christmas time, people are buying a lot of swords, but we also have trending spiking for seasonality. And there are algorithms that you can use to actually make better projections than that. We're not going to go that deep. We're going to use moving averages, and I think we're going to use moving averages for the last 12 months. So to do that, I would predict that the last 12 months was 217.91. I'm going to use that average as my projection for what month number 37 is going to be. It's probably going to drop me back down a ways, but I'm going to assume that this is a spike because of seasonality, and it will get me back down in accordance with a lot of these other data points. So that's what we use. That's how we could use moving averages. And it seems to me that 12 months is probably better because, again, of the anomaly that we see in the 6-month file. Let's look at it graphically a little bit. So we're coming through this the blue line, of course, is our data points. The red line represents the mean if we use all of the data points. And this better illustrates the trend that we're seeing. Even though it's a subtle trend, it still is a permanent trend. And you look at the fact that from about month number 22, we're above the mean of the entire data set. So we really don't want to use that. We really think that would be actually kind of off. For the last 12 months, we have the green line here, and that's our mean. And this is thrown off a little bit, again, by these two outliers that's pulling this mean up. If we were to drop those two outliers out of the equation, we would probably have something that would be much closer to all these data points down here. And I think, again, if we account for the seasonality and come back down in the 37th month, we'd probably be right back down here. This is our 6-month mean, running mean. Again, I think it's pulled up because of these anomalies. It's above every single one of the data points that are in the last 12 months. And so that doesn't seem to be a real representative measure of what we're looking at when we are looking at calculating a potential estimate for month number 37. Okay, our data suggests that the 36-month average is no longer relevant, so we'll go ahead and dispense with that. 12 months might work, but it could be underestimating, and that's only going to be the case if month number 37 stays up there with month 35 and 36, but that's probably not going to happen because of seasonality. 6 months might work, but it might overestimate, as we've talked about. So what should we do? Well, I've already pointed out there are two complications with this data set. One, trend is apparent in our numbers, which we saw because from month number 22 all the way to the end, we were above the standard mean for the entire data set. So we do have an upward trend, and there seems to be seasonality every 12 months, which I pointed out. So we have to really account for that if we're actually going to make projections that are several months out. We don't need to look at the graph again because we've already looked at it. I already talked about trend and seasonality. Trend is that our numbers are either steadily rising or steadily declining. Our overall average is probably not the right choice when we have trending. We're using moving averages. We just have to determine how many. And in our example here, we had a question as to whether or not it should be 12 months or 6 months. and we made an educated decision to use 12 months, because if we discounted the outliers in months 35 and 36, that would probably be a better fit. Moving average forecasts will typically trend behind the actuals. If you have a trending upward data set that is trending upward or trending downward, and you're using moving averages, which is the average of the last 6, 12 months, whatever choice you make, the estimates that you make will actually lag behind the actuals because it's going to take a while for that average to catch up. For seasonality, a good example of visit to national parks. Visit to national parks is going to be high in the summer and low in the winter. So how do we project? We project based on season. What we'll do is and there's mathematical processes to do this that we're not going to talk about today, but you normalize the data with a correction factor. There's a correction factor that will bring the summer numbers down and bring the winter numbers up so that they're about the same, and then you can make your forecasts, and then you unnormalize them and project them back to be summer high and winter low. Okay, your assignment. I have posted a call center staffing file. It is, I think it goes over the last 4 or 5 years. Gives you the number of actual staff that were required to staff the call center for regular calls and for urgent calls. And so there are regular urgent queues. There are 6 months left to be forecast. So your job now is to go through and take a look at the trends, take a look at whether or not the data are static and flat, whether or not there's trends in the data, and make a decision as to, would you use moving averages? Would you use just the entire mean? But give me your best guess at what you think the forecast should be in order to be able to staff out the call center. And that will be your assignment. You'll find that in the resources section, along with this, the slides from this presentation in the module 7.